Okay, can you hear me now?
Yeah, now it's fine. Now it's fine. Okay. Shana, could you please read the question once for me, if you don't mind?
Okay.
Because there was a problem with the recording. I was not able to record that problem.
Okay. So, a path of length 38 meters consists of 19 unshaded stripes, each of length 1 meter, alternating with 19 shaded stripes, each of length 1 meter. A circular wheel of radius 2 meters is divided into 4 quarters, which are alternately shaded and unshaded. The wheel rolls at a constant speed along the path from the starting position shown.
This also. This part also.
Oh, the wheel makes exactly 3 complete revolutions. The percentage of time during which a shaded section of the wheel is touching a shaded part of the path is closest to 20%, 18%, 24%, 22%, or 26%.
Okay. So I hope you understood the question. They said a path of length 38 meter consists of 19 unshaded strips and 19 shaded strips. They gave the length of the path, which is 38 meter. So you just imagine this like this as a road, and this one is the
Yeah.
wheel of the car. Okay. So the length of the road is 38 meter. So each stripe is 1 meter. So this one is going to be 2 meter and this would become 3 meter. So like that it goes on up to 38 meter. And we'll come back to the circle. The wheel of the circle is divided into 4 quarters. And they also said the radius of the circle is 2 meter, which means from here to here, it is 2 meter.
Yeah.
So now it's all about the contact between the wheel and the path. So when the circular wheel rotates, when the revolution happens, the circle and path meet each other, right? So
Yeah.
now you will be discussing about the circumference of the circle. You would be relating the circumference of the circle to the path. Okay. So we already know the circumference of the circle formula is 2 pi times r, right? So
Yeah.
it's 2 pi times. The radius is already given in the question, which is 2. So it is going to be 4 pi, right? So the circumference of the circle is 4 pi. If you notice it, they have divided the circular wheel into 4 quarters. 4 quarters, which means when this circle makes when the shaded part of the circle makes contact with the shaded part of the path, it looks like this. I'll just show you that. So this is 1 meter, and the circle is not proper, please ignore it. 4 quarters, right? So this is how it will happen. The shaded section of the wheel is touching the shaded part of the shaded part of the path. So if you
Yeah.
notice, only 1/4 of the circle circumference is in contact. Do you understand this part? Yeah.
Yes.
Which means it's 1/4 times of 2 pi r. We know the value of 2 pi r, which is 4 pi meter. So you're just going to substitute that over here. So cancel out the 4 and 4. You will have pi meter as the result for that. I'll just refer the solution once. Yeah. So the portion of the circumference taken by each quarter is pi meter. So as the wheel rotates once, the first shaded section of the wheel touches the path between 0 meter and pi is equal to 3.14 meter. What does it mean?
They're saying that the first quarter is touching
Path. They're
the
saying
path.
that the starting point is, we have to assume the starting point as 0 meter.
Yeah.
Okay, so actually it goes on like that, like 1 meter, 2 meter, 3 meter, 4 meter. Like alternatively, we will shade and unshade. It goes on like that. So when it touches,
That quarter finishes at 3.4 meters.
yes, exactly. Maybe from here to here. So when the wheel rotates once, the first shaded section of the wheel touches the path between 0 meter and 3.14 meter. So when it continues to rotate, the second shaded section of the wheel, second shaded section means this section, right? What happens? Like this will go upward and this will come downward, like clockwise direction. So when the second shaded section of the wheel touches the path, now the starting point is 3.14. Now the circle is here and it will rotate towards 2 pi. Do you understand this part?
Yeah.
So now the question is about 3 complete rotations. So now you have to check the number of shaded quarter will be in contact with the path over 3 complete rotations. In one complete rotations, we do have 2 shaded sections, isn't it? So for 3
Yeah.
complete rotations, you will be having 6 intervals, which means 2 intervals per rotation.
Yeah.
So it works like this. So they just drawn the table for that. In the beginning of the quarter, it's 0. End of the quarter, it's 3.14. Okay. So this
Yeah.
part is about the circular wheel. This is about the wheel and this is about the path. And what happens? And in the path, you have a shaded portion, unshaded portion, like that alternatively it happens. So it's 1 to 2. And 2 to 3 again it's unshaded, right? So you have to ignore that 2 to 3 because we are
Yeah.
only worrying about the shaded part. So now this is going to be 0, 1, 2, 3, and again you will have 3 to 4. Again you have to ignore 4 to 5, like that it goes on. So 1 to 2 it's shaded. Okay, so you're considering that. 2 to 3 it's unshaded, you're ignoring it. 3 to 4, like that. But 3 to 4, you don't have to go up to 3 to 4 because the circumference of the wheel, the contact finishes at 3.14,
Yeah.
isn't it? So you need to stop
At pi.
at point 3.14. So it's 3 to 3.14, which is 3 to pi. Is it clear?
Yeah.
So like that, you will have, for the second one, it's 2 pi. 2 pi means it's 2 times of 3.14. I hope you're able to follow it. It's
Yeah.
6.28. And then for the end of the quarter, it is like 3 pi. It's 9.42. So here it is like 7 to 8, 9 to 3 pi, like that it goes on. Could you please go through the table once?
Okay.
Shana, just give me a second.
Do I explain the table like out loud?
Shana, just give me a second, Shana. I'll just come back.
Okay.
23, right? I just want you to go through the table. You don't need to explain. Just go through it once. I'll just come back in a minute. Yes, Shana. I hope you are able to understand the table.
Yeah.
Okay. So did you get the interval part?
Yeah,
Did you get the
so
interval between the tables?
yeah, I understand where each number is coming from.
Okay. And here, why it is 7 to 8? Can you explain?
Okay, so let me just get my calculator. Okay, So from so the first person, there's like the white region, the unshaded region. So after the this is finished, the white region would travel 2 pi until 2 pi. And then so that would go until 2 pi. So then the gray one would start at 2 pi. So while the first one was the white unshaded region was traveling, um, it would pass through um, it's starting at starting at pi, so then it travels until for 3 other sections. So that'd be 4 to 5,
Okay.
4 to 5, and then 5 to 6, and then it would stop at 6 to pi. I mean 6 to
6.28.
yeah,
Yeah.
6.28.
Yes.
And then the
Start
next
from there.
one would start at 7.
So that pi part is for this, right?
Yeah.
I'm asking for the path.
Yeah, that's what I'm saying. So, there's one section in between the two, the first one and the second shaded region, right?
Yeah.
So that white quarter, it's going to travel for until 2 pi meters. So, I mean, it's gonna travel until 2 pi meters and start at pi meters because it's traveling pi altogether. So then during that time, it's the shaded regions it's going to touch. It won't touch. So there's 3 to 4, 3 to pi is the first shaded region. And then it's going to touch 5 to 6.
Yes.
And then it's not going to touch.
Yeah. The thing is like 3 to pi is shaded, and then pi to 4 is unshaded. So you're going to ignore
Yeah.
that.
So you ignore
And
that. And then you get 5 to 6.
yes, 4 to 5. When you reaches 4 to 5, you will get the shaded part of the path. But the thing is, you will lose track of the shaded part of the circle. So you're going to ignore that.
Oh no, I mean, so it will still be shaded. We're saying that the we're talking about the unshaded region right now, like in between the two, which is unshaded. So the unshaded circle is going to travel after the first one for shaded region travels from 3 to pi. The next section is 4 to 5, but that's unshaded. But
That's
we're
what
talking about
that's what I'm
shade.
saying. That is going to be unshaded part of the wheel, so we're going to ignore that.
Yeah, and then you look at 5 to 6. So then
Yes.
the white section is going to touch 5 to 6,
Yes.
and then 6 to pi.
Yes.
I mean 6 to 2 pi. And then so the next shaded region is going to start traveling at 2 pi and touch 6, 7 to 8 next. Instead of 6 to 7, it's 7 to 8.
Yes.
And then 9 to 3 pi.
8 to 9, we're going to ignore it. And then it's going to be 9 to 3 pi.
Yeah.
Okay. Okay. I hope the table part is clear.
Yeah.
So from there, we're going to find the total length of the shaded on shaded. So for finding the shaded on shaded, so it's 1 plus pi minus 3 because it is 3 minus 2. So why it is 1? You're just finding the difference of the meter, difference of the distance.
Yeah.
So 1 to 2, it's 1 meter. 3 to pi, it can be written as pi minus 3 meter. And again, when you subtract 7 to 8, you're going to get 8 minus 7 will give you 1. So it's 1 plus 3 pi minus 9 plus 14 minus 13 will also give you 1. And you will have 5 pi minus 15, like that. It goes on up to,
32 minus 10.
yeah,
And altogether, they're saying it equals to 16 minus 2 pi.
16 minus 2 pi is given in the question.
No, it's when you simplify all.
Oh, after the
I
simplification.
think
Okay, okay,
that
okay.
because you add these
You add
two.
all, yes, yes. So
Yeah.
it's 1 plus 1 plus 1 plus 1. Like that, you have 16 ones. Yes. So if you add it and simplify, you are getting 16 minus 2 pi. All right. So the total length of the path along which the wheel rolls is 3 times of 4 pi meter or 12 pi meter. Because we are going to find it for the 3 complete revolution, isn't it?
Mhm.
So which is why it is 3 times of 4 pi meter or 12 pi meter, because we're going to
Yeah.
find the percentage of the time. So for finding the percentage, you will write it in this way. Required percentage equals total length of shaded on shaded. We are worrying about this only, so that's going to be your numerator. And in the denominator, you will have, like total length of the path along which the wheel rolls. Like this part is
Yeah.
going to be the denominator, right? So which is why you do have 12 pi meter in the denominator and this total length in the numerator. And since you're calculating
Mhm.
it for the percentage, in terms of percentage, you will multiply it by 100 percentage. So if you
Yeah.
simplify, you're gonna get 25.8. This you can check. You just simply substitute the value of pi as 3.14. In the question, if it is given as 3.14, use that. Don't use 22 by 7 if they don't say, if they didn't give it in the option, because sometimes
Yeah.
they'll make that twist. They will also give you an answer by using 22 by 7 in the another option. So you have to be very careful whether it is in the question, it is mentioned as 3.14 or 22 by 7.
Yeah. Normally in Canada, we use 3.14. Like sometimes they use 22 over 7, but like
Okay.
most of the time it's
Okay.
3 point.
Okay, so if you simplify, we will get the answer as 25.8. So, so now they are, it is the 25.8 is very closest to 26. So we're gonna choose this option.
Yeah.
Okay. And you also say you have to discuss the question number 24. Roberta. Okay. Roberta chooses an integer r from the set 2, 3, 4, 5, 6, 7, 8, 9. An integer s from the set 22, 33, 44, 55, 66, 77, 88, 99. And the integer t from the set 202, 303, 404, like that up to 909. How many possible values are there for the product r, s, t? So this is probability. It's all about the cases. If you understand the substitution of cases, it's going to be pretty easy. All right. So we let A be the set 2, 3, 4, 5, 6, 7, 8, 9. You're just assuming this is A.
Yeah.
So first we note that integer S that Roberta chooses is of the form S is equal to 11 meter for some integer m from the set A, and the integer t that Roberta chooses of the form t is 101 n for some integer n from the set A, which means if you notice the set 2, it is the multiple of 11, right? Like 22, 33,
Yeah.
44. So which is why they are mentioning that as 11n. So if you notice the set t, it looks like 101 n.
Yeah.
Okay, I hope this part is clear. So this means the question is about the product of r, s, and t, which means you just gonna, I mean, r into m into n, right? So you're just going to multiply all the three. So you're assuming R from S, it is going to be 11m. We are assuming the integers of the set S as m. So it's going to be 11m. And we're also assuming the integer of the set T as n. So it's going to be 101 times n. So when you multiply all of them, you will have 11 times 101 times R into m into n. Is this part clear?
Yeah.
All right. So the number of possible values for R, S, T is equal to the number of possible values of R, M, and N. So we count the number of possible values of R, S, T by counting the number of possible values of R, M, N. This is here. You're just counting the number of values given in the set. Okay.
Yeah.
So if you notice, the set A contains only multiple of 5 and on multiple of 7. Furthermore, these multiples include only one factor of 5 and 7 each respectively. Okay. One multiple of 5. One multiple of 5 means it's just 5, right? And one
Yeah.
multiple of 7, it's just 7. Similarly, we count the number of possible values for R and N by considering the different possibilities for the number of factors of 5, 7 in R, M, N. Let y be the number of factors of 5 in Rmn and z be the number of factors of 7 in Rmn. So you're just going to assume two variables, y and z. Okay, let's go to the cases. So when y is 3, if Rmn includes three factors of 5, R, M, N, all of them are equal to 5. R, M, N is equal to 5 raised to the power 3. Do you understand this part?
Yeah.
How will you have 5 in M and N?
So if you choose a number with multiple of 5, so
It's
like
55, right?
yeah, 55.
Like 55 from the set S. And what about the set T?
505 from the set.
505. Exactly. So now we do have three factors, which is 5, 5, 5. So if you find their product, it's going to be 5 cube. If you choose 7 and you have 7 in the set R and in the set S you do have 77 and in the set
Yeah.
T you do have 707. Then you will have 7 cube.
And then if y is 2
2
and z
and
is
Z
1.
is 1. Here the thing is you would be calculating R, M, N includes at most one factor of 5 and at most one factor of 7 of each Rmn cannot contain both the factor of 5 and 7, which means
Yeah.
at most is 3. So at most is 3 means you are allowed to choose 0, 1, 2, and 3, not beyond 3.
Yeah.
So now we do check. And also they said it cannot both the factor of 5 and 7. So which is why we are calculating it separately as case 1 and case 2. It can't be together. But it is possible that y is equal to 2 and z is equal to 1. Because together 2 plus 1 will give you 3. This is allowed. You are getting the at most as 3. So you are
Yeah.
substituting y as 2 and z as 1, which means 2 of the Rmn is going to be the factor of 5 and 1 of the Rmn is going to be the factor of 7. Do you understand?
Yeah.
Maybe you will choose 5 and 55 and 707, or you might be you might choose 5 505 and 77, or it
Yeah.
uh could be 5
505
and 5
and
and
50.
55 and 7. Is it clear?
Yeah.
So it's 5 square times 7. So vice versa. What if y is 1 and z is 2? What if one of the Rmn is 5 and 2 of Rmn are 7? So you will have 7 square and 5. Okay. And what if you have y is equal to 2 and z is equal to 0? It's still lesser than 3, but it is allowed because we are just comparing, we are just checking for utmost condition. So this is allowed. So 2 of Rmn must be equals to 5 and third cannot be 5 or 7. Of course,
Yeah.
there is a chance you can choose the other thing, right? You can choose the other 6 values. You can choose 606, 808, 909, like that, right? So you
Yeah.
might be able to choose the other 6 values. So here you might be able to have 6 possible values for Rm in this case. Um, Wait a minute. 5 into 7 square. Okay. Could you multiply and check their answer, whether you are getting only one possible answer? Can you please check for this and this?
Okay.
We saw all those 3 options, right? Could you please check all those 3 options and check whether you are getting the same answer for all the 3? You can use your
Okay.
calculator also if you don't want to waste time.
Yeah, it's right.
Okay, you are getting one possible values. That's great.
Yeah.
So you're repeating the case for y is equal to 0 and z is equal to 2, the vice versa. Again, you're going to have the 6 possible values for the product of RMN, and you have to check what if y is 1 and z is 1, and what if y is 1 and z is 0. So when y is 1 and z is 1, one of the RMN equals 5, one of the RMN equals 7, and the other must be one of 2, 3, 4, 5, 6, 8, 9. So in this case, again, you're going to have 1, 2, 3, 4, 5, 6, 6 possible values, right? And when y is 1 and z is 0, you are allowed to have 1 also. 1 plus 0 will give you 1, which is lesser than 3. This is also allowed. So when you check this, one of the RMN equals 5 and none of these equal 5 because z is 0, which means you're not allowed to choose 7.
Yeah.
Again, you're going to have yeah. Okay, here it says they explain that. Suppose if you have R is 5, suppose if you have R is 5, each of M and N equals 2, 3, 4, 6, 8, 9. Which means it could be 22, 33, 44, 66, or 202, 303, 404, 606, like that. Do you understand
Yeah.
this part?
Mhm.
If you choose R from the set A and these factors from set S and set T. So
And
the
then they're
question is
finding
to
all
find
the
all the possible values. Yeah. So it is better to put them in the form of a table. So it's 2, 3, 4, 5, 6, 8, 9, 2, 3, 4, 5, 6, 8, 9. So you know how to find their multiplication, right? You just have to find 2 into 2, 2 into 3, 2 into 4, like
yeah.
that, like that, 2 into 8. Like 6 times of 8 will give you 48. 8 times of 9 will give you 72, right? So you're just
Yeah.
doing multiplication table here. So you got like 4, 6, 8, 12, 16, 18, 6. Again, you are getting some repeated value. You are avoiding you just ignore the repeated values and just write the different values alone. So you're having like 16 terms. So therefore, there are 16 possible values of R, M, and N in this case. I
And then
hope,
the same thing
yeah.
for 9.
For vice versa, also you will have the same, isn't it?
Yeah.
When y is equal to 0 and z is equal to 1, you're going to have same kind of answer. Only the position, varies. Since multiplication is commutative, you don't have to show that again. So we can directly conclude that this case also will have 16 values as the case 8. And in case 10, we're going to have y is 0 and z is 0, which means none of the RMN is 5 or 7, which means you're going to ignore 5, 55, 505, 7, 77, 707. We are going to ignore all these values. Do you understand?
Yeah.
I think the meeting is about to end. 1 minute, I'll just organize again.